are all on the page is that all contributed or they've been part of the work that has delivered these programs. So we've got CFAS, which Serena is representing. We've also done a large program with ICAT, so the Regional Fisheries Management Organization for the Atlantic in terms of tuna, and some of the other species have been doing a large amount of the work in terms of assessing kind of stocks and resources. We've also had a Darwin Initiative project that originally looked at some of the tuna work, and then some others with some other work as well in terms of some detailed analysis and tagging work with Stanford University in America. So I'll explain a bit more about how those have come to programs as we go through. But yeah, if we can jump to the next one, Serena, please. So yeah, St Helena itself, for those who don't know, we are that little dot in the middle of the South Atlantic Ocean. You can get here now by a flight, but until about 3 or 4 years ago, the only way to get here was a 5-day boat journey by sea. So we're 1,900 kilometers from the African and Angolan coast, and we're in the South Atlantic Gyre, which is an anti-clockwise kind of circulation of water that moves up the west coast as the African, Benguelan and Angolan currents. And then the slide that Serena was going to bring up, I think. So St Helena in 2016 designated it has an EZ, and it designated a Category 6 marine protected area of 200 nautical miles, which is the area that you can see shown. So we have, the island itself is a 14 million year old volcanic island. And if you could jump onto the next one, Serena, for me. It's 800, the top of the island is 820 meters above sea level, and it's roughly about 120 kilometers squared. So what we'll see here is, this is a bathymetry image or video of some of the work that was done across a few different surveys that we've had. But where it's finished there, I'm not sure how well it came through for everybody else. It's quite jarry for me, but basically to show it again, what you're able to see is that we have quite a shallow shelf to begin with, for about 200 to about 200 meters depth, which is about a mile out. And then basically from there, we go from the 200 miles very rapidly to the sea floor, almost to 4,000 meters in depth. So what that kind of does is we get a big upwelling of currents, which brings nutrients and kind of stimulus, and the primary production starts to happen. And then we have the abundance of zooplankton, and then that brings bait fish. And then following through the food chain, we start to see tuna species and then other larger kind of pelagics as well. So quite plentiful in terms of the waters in and around the island. Just about the population, we're about 4,500 people. The fishery, the island has a fishery. It's traditionally artisanal pole and line, which you can see one of our main fishers there, bringing in tuna on the pole. And the catch on each year, roughly somewhere between 100 tons to 800 tons, with an average of about 350 tons a year landed of tuna. And then other demersals and groundfish species landed in much smaller numbers in and around the island's waters. The sales of the tuna are approximately 155,000 pounds per annum. But the exports, that's locally, and then the export side of things are somewhere ranging in around the 850,000 pound mark. But the island's going through a bit of a change at the moment in terms of its fishery. So the fishery has previously been kind of subsidized or underpinned by the government. But now we're in the process of an investor coming to essentially, some of the market has gone to a private sector essentially. So the fleet size is kind of 10 to 12 full-time tuna vessels. And then I'll talk a bit more about it later, but there are 2 seamounts, which are a distance off nearer the edge of the economic zone that 2 of the vessels actually go to and fish. So I've talked about, yeah, there's the potential for the expansion and the investor. But Serena, if you could jump onto the next one for me, that'd be great. So the programs that we've been doing, what we've been trying to do, just understand that similar with other overseas territories is often there's a lack of data or an understanding around certain species. And so we've been trying to improve our understanding and the knowledge of those. We have got landings data that ranges back, but it's patchy in certain periods of time. But it's all about trying to make sure that we've got locally appropriate management methods as part of that marine protected area in terms of managing our tuna resource that's part of a wider Atlantic stock, basically. So yeah, if you could jump onto the next one, Serena. Thank you. So I did mention when I talked about all the different logos that were on the screen earlier, we've had a variety of different projects that have helped to look and understand those kind of resource assessments in relation to the tuna stocks. So it kicked off with the Darwin project in 2016-17, and then has been heavily supported by the UK government's Blue Belt in the 2017-18, but a lot of the actual analysis work for the Blue Belt has continued along throughout that period. And I think the reason why I wanted to bring up the Blue Belt in that way is it's provided us with access to resource and expertise that we definitely wouldn't have on the island, and we wouldn't be able to afford or have access to. And then, so our regional fisheries management organisation, ICAT, carried out a large piece of work in terms of a tagging programme for 3 years, which we deployed a large number of tags, which again I'll talk about later. But that is, so as much as we're doing information locally, that's how it feeds into a wider global understanding of tuna and kind of their movements as well. So we've been able to carry some of that work on locally, although it's quite reduced in terms of the budgets that St Helena has available to it overall as a government, and then kind of what comes as for marine and fisheries work. And then I talked briefly about some of the analysis work that had been done alongside that to try and it's, I'll explain a bit later, but it's fed into our decisions in terms of kind of size limits, quotas and things like that, basically. So yeah, Serena, if you could jump to the next one for me. So just to explain a little bit about what we've been doing. So the resource assessments can be done in a variety of different ways, but predominantly what we've actually been doing is a large-scale tagging program on yellowfin tuna. So we've actually been going out with the local fishers, landing those fish and having to do it in a slightly different way to how they'd land them traditionally, because you need to make sure that you keep the fish in a decent, not quality, but as in you need to not be harming the fish. And then, so they're actually, the bulk of the information that we've got gathered back is from these conventional dart tags, which provide you information about, so you know when you tagged the fish, where it was, what date it was, and then we will also record the length. And then you get, when it's recaptured, you get that information back again. So it allows you to work out where it's moved to and how much it's grown and things like that. The satellite tags are kind of a lot more sophisticated. They provide you a lot more detail about the depth the tuna goes to, its daily position, and also temperature profiles. So you get to see, and we can start to compare that to things like some of the CTD casts that we've been doing. And it also gives you information about some of the activity levels as well. So Serena will talk a little bit about how you can work out kind of feeding behavior, things like that from that movement. Similar some stuff in relation to the data storage tags. So these actually get, both those and the SAT tags kind of get actually sutured into the fish. The difference being is the data storage tags, you actually need to get the fish back to get that tag back. And then the acoustic ones, they're quite cool. I really like these. They essentially work like a barcode in a supermarket. So we put out a receiver and the acoustic tag that is attached to the tuna will ping that barcode or that receiver, and it will scan and it will say so-and-so tag tuna was seen at X period, X time. So yeah, if you could move on, Serena, for me. So these are just a few images of that work being undertaken. So as I mentioned, the fish, it's really important to land them and make sure they're kind of safe and secure when you land, when you bring them in. And then it's a simple dart that's administered via the tagging needle that you can see in a couple of those photos there. Trying to minimize kind of the distress to the fish, so covering the eyes and then putting it back in a safe way, so not holding it by the tail and things like that, or using the cradle, as you can see in the bottom there. The next one, Serena, for me, thank you. So these are these two are the satellite tags. So these are two of my team, so you can see this is actually when Serena was doing some training with my members of my team to actually kind of install or suture those satellite tags into the fish. And there you can see one. So they're actually working on a cadaver here, obviously. But yeah, so it's another thing just to talk about in terms of the Blue Belt program, in terms of the capacity building, that it's really helped to upskill some of the local staff. So I'm not local, I'm not St Helenian, but members of my team are, and those skills will hopefully remain on the island much past kind of the end of the programs, essentially. So yeah, we've got a quick video now just kind of showing a little bit about that work and the deployment. So yeah, I've already talked kind of about where we are. So so it's been a significant number of tag deployments, over 5,000 over that period of kind of 5 to 6 years, which is a lot. And here you can see they're cradling the fish on, and then the tag being administered, and then the release into the water. So hopefully you might be able to spot the tag in the back of the fish just at the top there. And it's really important. We've been working with the local fishermen to do this, and in many instances they're actually carrying out a large amount of the tagging independently now for us, kind of, and we reimburse them for that. And then also similarly provide them being the ones giving. So we provide a reward system for the tags, so it helps us to get that information back, essentially. So yeah, so just a bit more in terms of what we've seen or what we found, and to explain a bit more about the fishing activity in itself. So you've got the island at bottom right here. So this just explains a little bit, or that image shows a little bit more about the depth profiles and that kind of the pelagic shelf that I was talking about, and you can see in that video. Large amount of the fishing is done inshore. So we predominantly, probably 95% of the fleet actually fish in and around those areas, in the area labeled D there. And then, so we have down in C, that is Bonaparte. So that's about 80 nautical miles off St Helena. And it's about 120 meters deep. So again, even though it doesn't crest the surface, it provides that upwelling and is very rich in terms of its productivity and attraction to larger pelagics. And then further to the very north of our EEZ, we also have Cardno Seamount, which is actually made up of sort of a number of smaller seamounts, which is very highly productive. So yellowfin tuna are mostly found in and around the island and Bonaparte, and then big eye are largely found out at the main bank, and more at Southern Cross. It's yellowfin are found at the main bank. So you can also, that gives a bit more context in terms of where we are in relation to the coast of Africa and the Gulf of Guinea, which will become important in a second. So if we could jump to the next one, Serena, for me. So I won't dwell on this one too long, but it was just to try and explain about those volumes of tags that we were putting out in terms of the nearly 6,000 now to date, and looking at the number of recaptures and the kind of percentage recapture rate that we've had over the period of time. And obviously, not always, but the larger amount of tags that you deploy, potentially the more likely you are to get more returns, but not always. So just the final thing to highlight on that slide is the average kind of recapture rate is around 23%, which is, it's a little bit higher than most conventional tagging programs, but there are, there's a reason for that, which I'll explain kind of in a second. So we could jump on to the next one, Serena. Yeah, so in terms of the tag recoveries, conventionally, if it might just be easier if we put all of them up at the same time, Serena, or yeah, so we've conventional tags, we've had a return of about 22%, and in the number in brackets, so the number, the first number is the number we've deployed, and then the number in brackets is the number that we have recaptured. The other thing to highlight on this, which is kind of interesting, is that the different areas, because of the fishing effort or the fishing pressure, has got different return rates. So we generally have a very high return rate in and around the island itself, less so at Bonaparte and Cardno. But you can see from the different types there that we've had a very high return rate of the DST tags and getting that information back. So it is great that you're getting that information back and we're getting lots of data, but at the same time, it is in certain instances indicative of a higher rate of mortality of fish, basically. So yeah, if we could jump on to the next one, Serena. So yeah, this is just to try and explain what I was saying there about the difference in where we've deployed and recaptured. So what we've generally found is that from, as you can see there, the high numbers of the sort of the smaller fish, which we generally see inshore, are recaptured inshore over that period. So we don't see a large amount of movement away from the island, certainly not ones that are tagged inshore outside the Z in any way. Slightly more movement in the slightly larger fish, but there's a reason for that, which I'll explain in a second. And then again, similarly with Bonaparte, high numbers of fish that were tagged remaining in and around the seamount that they were tagged at. And then Cardno, slightly different. So we've got more movement there from Cardno. So that's the one that's the very north of our 200 nautical miles. More movement outside the EEZ, but still very little, but most of that movement off to the Gulf of Guinea, which we potentially think is as a result of kind of spawning activity. So what, if we jump onto the next one, Serena. So yeah, so the question about where do they go, if we could, so we generally see that what happened, sorry, Serena, if you could just jump back a second, where do they go? So generally there's a large amount of site fidelity of those tuna inshore, and they tend not to move off, but after about 1 to 2 years, they do move off. And then what we start to see then is a movement to Bonaparte, which is the nearest seamount, and then further on to Cardno after that, and then sometimes a movement outside to the Gulf of Guinea. And what that's tending to show is that growth, essentially. So if you liken it almost to the island itself being a nursery, moving on to more juvenile or beyond juveniles, and then kind of the larger adults being out at Cardno. Obviously, this has kind of impact or implications for your management of your fishery, because you've got high site fidelity or large amounts of the tuna remaining in and around the locations and the island. You want to make sure that you're not overpressuring or overfishing that, certainly at certain times of the year. So yeah, so overall we had 21 recovered outside of St Helena's waters. And then we did also have migration from one that was released in Abidjan as part of that ICAP program and recaptured in St Helena. So that's just kind of showing some of those recaptures. So you can see they're not particularly localized either in terms of where they are or where they aren't. And then if you could move on to the next one for me. So this is just to highlight what I was saying about that size progression. So the recaptures of tuna inshore is around about 85 centimeters on average. And then moving on to Bonaparte, the size has increased slightly to about 100 odd. And then Cardno being kind of more the 112. So you're starting to see the larger fish as you move further away from the island itself. And then moving on to the spawning grounds potentially after that. And then the final one, I mentioned that we'd had, or the final main slide is that I mentioned that we'd had a large amount of kind of landings information across a period of years. But what we'd also done was, you can see here the landings by years. So you can really start to see that size progression at the different locations and throughout the year as well. And then the next slide, which is, or the next part, which is that this is really to try and emphasize that we almost end up with yearly cohorts, much like school years, that move through those waters through to different locations, essentially. And that overall, from everything we've seen, it does indicate a period of residency in and around the island's waters. So, and then the final piece that I was just going to talk about, which is part of the summary slide, but that the implications for that in relation to management practices is that we've been able to bring in a minimum landing size based on that information about the level sizes of the catches. So we know that the size of maturity. And then also we've been able to work out a biomass assessment. So we've been able to actually introduce total allowable catch figures, which are separate to our regional management measures, which ICAT kind of impose on the UK and the overseas territories. So those programs have all been instrumental in gathering a lot of that information, and it has shown us that there is a high proportion of kind of site fidelity and residency as well over a period of years. So that's probably it for me. I just wanted to, the final thing I wanted to highlight was on the final slide was the programs have been instrumental or not instrumental in helping us understand the species better, but also we wouldn't have been able to deliver them without the local fishing fleet and being able to do that work, and also the knowledge they've been able to provide us. So it's been a real success in that way as well. So yeah, that was probably, I think, everything from me to begin with, and then Serena's going to talk a little bit more about some of the detail of some of those findings.
Okay, yeah, thank you, Rhys, for that. I'll move on to, we've got a little bit of time left, I suppose. You know, we wanted to try and make sure this talk's kept to about half an hour, I think, of the time allotted. So what I'm going to talk about is using this same information. We've got to kind of more complex understanding of the population within St Helena waters. So in addition to the work that Rhys has been talking about in the previous presentation, we've also used those electronic tags to better understand the movements whilst they're within St Helena waters. And that's basically what I'm going to try and summarise for you today. I'll try and keep it brief, just so that we've got time for questions at the end. But yeah, so that just kind of shows you where we've moved on from this. But again, same acknowledgements as Rhys had mentioned. This isn't just work between St Helena Government and CFAS and Bluebelt. There's a lot of contributions from other organisations like Stanford University, the Darwin Initiative, and ICAT. So just to summarise what I'll try to go over briefly, and Rhys has mentioned the fact that, you know, yellowfin tuna are very important for St Helena, and you know that the landings there are very important as an income source. So we're trying to better understand why there is changes in landings throughout the year and what that could be attributed to. So this presentation just explores whether changes in landings by the local fleet can be attributed to bottom-up or top-down pressures. So that looks at basically the availability of the tuna to the fishing fleet that operate locally, and the accessibility of those tuna to those fleets. Because we know that they're spending prolonged periods, at least for the first few years, within St Helena waters, but we do see a change in how much tuna is coming through the doors, basically. In this presentation, I'll start off giving a brief overview of the fishery. I'll then talk a little bit about some of the data collected from the electronic tags. So the depth use, so where they are in the water column and how that can change with things like the lunar phase. And then I'll talk a little bit about how we use some of the fancier technology within those tags, things like the acceleration recorded, to better understand how that behaviour changes through time and how that can impact landings locally. So just to briefly summarize the local fishery, this shows the mean landings by month for the local fleet. And I'll just play a little video whilst I'm showing this of the local fishers fishing at the seamount of Bonaparte. But we can see here that between January and June, that's kind of the best part of the year to catch the yellowfin tuna. And we see a real reduction in the quantity of tuna coming through the St Helena government cold store in the months between August and October. So we're just trying to look at what is driving that change in the amount of tuna coming through the doors. So we used the electronic tags, as I mentioned before. So the PSAT represents the satellite tags. So we used 3 of the satellite tags, which recorded temperature, depth, light, and acceleration up to 232 days after release. And then we used the data storage tags, the DSTs, to look at, again, temperature, depth, and light, to try and explain what's happening in terms of their behavior. So as of 2020, there were 27 recoveries. We've had a lot more back since then. So there's going to be more analysis on those in the coming years, is the plan. Just to summarize the kind of information that's recorded for all of these tags, the electronic tags, this plot shows the depth, the water temperature recorded, and the body cavity temperature. So the depth experience of all those tuna combined shows that they spend most of their time above 100 meters in the water column. So 94% of the time is spent shallower than 100 meters. One of the tuna, the deepest that we've ever recorded for St Helena was down to 1,000 meters, 1,014 meters for one of the yellowfin tuna. And then if we look at the temperature experience for the tuna, we can see that they like to spend their time in the warmer surface waters. So that's like 88% of the time above 20 degrees. And the body cavity temperature is slightly raised compared to water temperature because they can, it's partial endothermy. So they can raise their temperature slightly above the ambient temperature of the water, which will help things like digestion and stuff like that. So if we look at what some of this information looks like and an example track, this plot shows a Julian day on the bottom axis for 365 days of the year. And on the y-axis, we can see from 0 to 24 hours. So the time is on the y-axis. I've just shown you that basically at the bottom and the top of the chart, you'll see the night phase, and in the center, it shows you the day. So basically what we do here is we overlay one of the variables. So for example, this is going to be depth. So each point represents depth recorded at a particular minute in time. So this is a full track from one of the sampled yellowfin tuna, and we can see them spending most of the night time in shallower, darker blue, which represents them being relatively shallow. And during the day, that's when they're doing their deepest dives, which is represented by the lighter green and yellow colors here. Some of the interesting points to pull out from this, you can see right at the start of the track, the depth experience of the tuna suggests that they're relatively shallow throughout the day and the night, so it's dark blue throughout. And you can also see that at the end of the plot, showing that they're switched like in November, December, as they're shallow during the day again. And then kind of in the center part of the chart, you can see them starting to do something called DVM, diel vertical migration, where they're spending more time deep during the day. And you can see the deepest points, whether it's kind of 500 meters or deeper, as the yellow during those days. So those are the deepest dives individual. One interesting point, if you squint, I probably shouldn't say if you squint, but in the night you can see there's kind of stripy patterns. It looks like a nice stripy patterns throughout the year. And that if we overlay the lunar illumination, so whether it's from a new moon to a full moon, which would be the one in terms of the lunar illumination, you can see the stripes align with the lunar phase. And if we plot that in a slightly different way, and this is basically pulling out all of the night depth experience and showing how that relates to the lunar phase. The average nighttime depth appears to change depending on the lunar illumination. So when it's new moon, so when it's very dark and up to kind of about half moon, the yellowfin tuna are shallow, they're kind of at 20 meters. But as the level of illumination increases, so as we approach a full moon, you can see them spending more time deep. So them shifting their kind of behavior depending on the illumination, which we anticipate is due to them trying to feed on the prey that are kind of trying to hide from them because it's getting brighter during the night. So that's a little look at how they behave during the night. But more importantly, to align with the behavior of the fishery, we want to look at how they behave during the day. So that's what the next slide is going to show. So this is an example track over a single hour in the life of a yellowfin tuna from 9 to 10 a.m. The top shows the depth experience. So you can see them spending most of the time above 50 meters for the first 45 minutes. And then they do a nice deep dive down to 200 meters at about 9:45. And as I mentioned before, we use slightly more complicated technology for some of these animals, and we record acceleration, which allows us to look at the orientation of the fish, so whether the pitch angle is high or low. So that's the second plot. So that makes sense there because you can see that them traveling relatively stable at the kind of shallower than 50-meter depth, and then the pitch dips as they do their descent, and then they ascend again at the final part of the chart. So then if we use the acceleration again to look at the level of activity level. So if you imagine acceleration is like the G-force you record in your phone. So if you shake your phone and there's games you can play on your phone which use acceleration, it's the same principle. So we're seeing the activity level of the tag on the tuna. So it can allow us to look at the kind of the high intensity events, which are likely events like striking at prey, for example. The bottom plot, which is the MA, is the combined acceleration, so the overall activity level. And the points at which there are kind of really high intensity periods, you can see it's occurring at the bottom of the drive, suggesting that the tuna are striking at prey right at that 200-meter mark before returning to sort of surface waters. So we use that principle to look at how they change their behavior through time and where in the water column they're feeding throughout the year to help better understand the change in that availability in the fishery. Sorry, it's really hammering it down outside. I don't know if you can hear that. It's really raining hard. I hope you don't hear that over the line. So to the next point, so as I said, we use this information to look at how activity level changed throughout the year. This chart basically shows a 24-hour period over a single month, and we just combined to show the location of where these fast starts or burst accelerations are occurring. Between 0 to 5, that represents night, and after 2000 hours to 25, that represents the night as well. So it shows you the time of day and where the strikes are occurring. You can see here that most of the strikes occur in the surface waters during the night, and then when we get to daytime, they're more down at the 100-meter mark, and that profile seems to stick, especially if we compare how that changes throughout the year. So this chart shows from January through to June for an individual, and we see that surface fast start behavior in the first 3 months, so until March. And then as you can see, there's kind of a blob of high activity levels down at about 300 meters, which starts to increase as the year progresses. It's that principle and the fact that they're shifting their behavior to deeper grounds as the year progresses that seems to be driving the change in availability. So if we show that in a slightly different way, if we look at the time spent in the surface 100 meters by month for all of the individuals combined, we see that as a real clear shift. So that July and through to October is when they're spending more and more time deep and deeper than 100 meters, potentially feeding on those prey items down at the deep scattering layer. Compare that to that original chart we showed at the beginning, the mean landings. There is a nice correlation there with the lowest catch of these tuna occurs between August and October, when there's less time in those surface waters. And again, if we plot that as a point chart, even is the normal way to refer to one of these, we can see that the correlation between the percentage time spent shallower than 100 meters and the overall landings. With the months and years where we see the highest catch being the months and years where, they're spending most time, more than 90% of the time in surface waters, more accessible to the fleet. Yeah, just to finalize a summary of that. Another point which we try and emphasize in this work has been the fact that for fisheries, we're often using catch and effort data to better understand, the models of tuna availability to the fleets. But we also need to better incorporate things like the behavior of the tuna within these models. So in addition to just using the catch statistics, we need to understand, they might actually still be within the kind of area that you're fishing, but they're not accessible to the fishery because behaviorally they might be doing something different. So this chart here just shows you the daily positions of those yellowfin tuna, and the charts on the right and left show, no, it's not on the right and left, on the right show you the average depth for those individuals during the day and the night. So the chart on the left showed the fact that they're very much staying close to the grounds that they were released, but the vertical movement is shifting to more time deep, which reduces their availability during those winter phases. Just to finish up on that, I would want to obviously say thank you for listening, and to obviously all of the people involved in this work. We just had both of these papers accepted in the last few months, so they are available online if anyone's interested. And I thought I'd finish off just showing some of the tuna actually in there up below one of the boats. This is at one of the seamounts. You can see one of the tuna currently on the line, and in the deeper waters you can see some more of them on their way up, which is just quite a nice visualization of the fishing effort and the fact that how these tuna behave in the natural environment. That's the end of that.
Awesome, thank you so much. That was really interesting. I love those videos right at the end. Cool. So I mean, I'll open up to questions, but I have a quick question. And my question was related to I love the fact that when you're host, you get to just like go first all the time. So my question was about the strikes and the depth and stuff. And so am I right in understanding that they're visual predators? And so when there's more light penetration, they'll go a bit deeper, right? But 300 meters to me sounds really deep. Like, is there still light penetrating that deep, or are they able to use other cues? I mean, how do they find prey that deep?
I think based on looking at some of the information from the acceleration, we can see that vertically they seem to be tracking the deep scattering layer, which comes shallow in the night. And so as soon as sunrise hits and the deep scattering layer starts to migrate down to kind of the 300, 400 meter mark, the tuna are following them visually, because they're like, oh, actually, now we can see you a bit better. Let's try and eat a bit more of you. And then actually when we've looked at the timing of the strikes, I didn't go into detail in this presentation, but in some of the others I've shown, they actually wait until they are underneath the prey. So the strikes occur and the pitch angle of the tuna is very much that way. So they are clearly, they can't strike at them when they're facing down, but they have to get below them and then strike up.
Like a silhouette kind of thing. Interesting. Okay, and then so on the same lines, am I right to assume that big eyes, because they have bigger eyes, have better eyesight? Like, do you see the depth increasing for big eyes compared with, say, yellowfin?
One of the other studies that we haven't actually published yet because we haven't had sufficient big eye data, we did a comparison of the big eye and yellowfin behavior. They're much deeper. They don't really spend that much time in the shallow surface waters compared to yellowfin. And there does seem to be that kind of, they just prefer to be in those deeper grounds where they can, better utilize the prey at the kind of the deeper waters. So, Rhys, did you have anything on that one?
I know if you've answered that one well. I'm not going to add anything more on that yet.
Do we have any questions out there? I do have a question for Rhys as well, but I'd love to hear someone else talking, not just me. And you can take your videos off now. I think we're okay for bandwidth. If anyone has any questions. if I'm being a bit shy, or is there one? Oh, Leanne has to go to talk. Has to go. Okay. I did have a question for Rhys. And it was, you just sort of like threw it in there, but really didn't give any detail about this kind of like private interest. And I can cut this bit of the video if you don't want to talk openly. I'm just curious, what did you mean by that? And like, I mean, I don't actually know that much about fisheries management and, you know, how it works with government versus private and so on. I mean, what quandaries are you facing there?
So the reason I looked distracted when I was saying that was that the phone was ringing and someone was at the door. So it wasn't I was trying to be obscure with my answer in relation to that. No, so basically the fishery here has had predominantly because of being a small remote island, a large amount of kind of the industry has often been kind of nationalized for kind of food security purposes and things like that. But in terms of, but as a result of that, they're often not particularly, not always particularly viable, if that makes sense. There's been the opportunity to kind of, for the government to sort of step back a little bit, especially with things like cuts that are happening, to be able to utilize kind of private investment to some of that sector. Now, both with fishing being very important culturally and to the island, you need to make sure that that's done sensitively. So the way that it's actually been done here is through, it's a private investor from overseas, but it is also through a local cooperative. So it's about trying to make sure that the island maintains that stake or that involvement in its fishery and how it's run, essentially, rather than just essentially kind of selling it, you know, selling that fishing off to a private entity, essentially. The quotas that we're talking about, I didn't talk about numbers, but it is small. I mean, we're talking 300 metric ton for yellowfin and 600 for big eye. So when you compare that to some of the longline fleets and things like that in terms of what they're landing a day, it's nothing really. So yeah, it's not, and basically it's just that the change is happening now. So the new investor has taken over and they are kind of moving towards a sort of opening and providing for that local market and also for overseas, essentially. But
would they use? So would they also use pole and line, or would they use?
Yeah. So no. So we've got, as part of the MPA, but also our policy and our legislation, it's very strict in terms of. So they are local vessels that will be fishing. So it's not like it's a foreign fishing entity or anything like that, but they will be subject to all of the same license conditions that currently we have in terms of pole and line, different gear type, not allowing to other types of gear and things like that. So,
oh, great.
But it's important, just I suppose the one thing about your question, to stress that if you don't have some of those safeguards in terms of your policy and legislation, which some of the OTs don't necessarily, it does leave you, I think, vulnerable in terms of to the wrong type of investment in some ways.
Cool. Oh, thanks. That was a great answer. Do you have any other? Luke, you put your video on. You gonna ask a question? Not really. I did have one other question actually, given that I'm just love tuna clearly, but please, everyone, don't be shy. One of the, well, Serena, your little animation was very cool because you could see the individual movement patterns. But then one of the still images that Rhys showed like a kind of, it showed like a position and then a long line and another position. And it tended to be like, you know, St Helena, Seamount 1, Seamount 2. And I just wondered, is that because they have to come to the surface to beam that data up? Like, I'm assuming they are kind of wiggling around on their way there, or do they really just like know where those seamounts are and they're going straight to them? I kind of just wondering about that.
Rhys, you want to do that one?
Yeah, so I think Anna, if it's the one that I'm thinking you're talking about, the line sort of generally represents the overall movement that they've made. And then, but within that, there will be, as Serena was showing, kind of with some of those plots, there will be different depth variations within that. So it doesn't mean to say that they've just gone to one and popped up to the other. It's just perhaps the way we've displayed the data in terms of the final location where they captured, essentially, rather than what they've been doing between the two. You get that more granular from the satellite tag when you download it, or when it beams up to the satellite. Yeah.
Yeah, okay, that's what I thought. Yeah, okay. But does it have to be within a certain number of like meters of the surface to actually beam that information up?
So Serena,
PSAT?
I'm wrong because she's the satellite tag expert, but you get a lot more information when you actually recover the tag. But they're scheduled, they've got an inbuilt kind of redundancy where they do pop off eventually, and they have to come to the surface then to beam that information back, basically.
Okay, that makes sense.
That's right, Rhys, as well. And just to say, within that there was conventional tags as well. So obviously you get a point-to-point start end, and we don't get anything in between. So that's why it's kind of nice to do a combination of the conventional tagging with the electronic, because we see, you know, a lot of recoveries from the same area, but because we don't get the daily positions from the conventional, you need that satellite or electronic tags to say, well, you've got the endpoints and maybe it's 360 days after the release, and it's like, well, what happened between them? And the electronic tags help to show that kind of daily, they're still bubbling around the same areas.
And then you just need to get the eyeballs out, and then we look at what they've been eating as well. Easy.
Peel the eyeballs out. Exactly.
Yeah, exactly.
The plan.
We'll need a bigger freezer for the big eye, won't we? So everyone's been very shy today. I think everyone's end of term crazy. But anyone else got any questions? Like I've hogged the floor. Everyone's being a bit quiet, but that's good for your meeting, Serena. You'll be there on time. But thank you so much, Rhys and Serena, and everyone for joining us today. It was really, really interesting. Very, very cool. Yeah. Oh, we've got some little comments in the chat. So yeah, thank you all, and we'll see you next week, same time. Yeah.
Thank you.
Thanks, Rhys and Serena. Take care.
Bye.
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 Bye.